All right, this room is really full. That's awesome. There's some room up front if you want to sit on the ground and not stand in the back. That would be cool. Also, the first thing that you need to do.
There's some extra.
There is.
Bean bags too.
Oh, there's extra bean bags even. No, there's not.
Yeah, there's two. There's an orange one and
okay.
another orange one. So you should make your way up now if you want to do that. Also, it's going to be really hard to type standing up on a laptop.
Yeah, so this is really interactive, and you will be coding.
All right.
Awesome. How many of you have used Go?
Oh.
That's a fair amount of the room. How many of you are not developers? None. Sweet. This is going to be easy. This might be too easy for you guys. This is going to be fine. All right, so we are building a CLI app in Go. That's why we're all here. That's us. We already did introductions, so I'm going to kind of skip through this, except for we're going to appreciate Steve eating a taco. It was Torchy's Taco in Austin. It's the best taco. So what we're going to talk about today is the designing the experience and then building the app. So first we'll sort of interact and talk about what we're going to build, and then we'll start building it. So as I said, this is going to be really interactive. We want you guys to participate. So we're going to ask you guys lots of questions. And also we are following the 50% rule. So if you're behind, wherever most of the room is where we're going to be. Luckily, the slides are pretty decent, so you should be able to catch up pretty easy.
It's a little extra time. That is the URL to the slides we are using. It is not easy to remember, but it is short.
I'll give you guys a second to get that. We good?
Nope, they're not good.
Not good?
Not good.
All right, not good.
It was 4 groans.
I think we're good now. We good?
Do it and see if there's
You
groans.
guys got it? Sweet. All right, so the first thing that we're going to do is check our Go environment. I'm a relatively new-ish Go developer. Steve is not. He's on the Go team at Google. He's really fancy. Yeah, whatever.
Yeah, definitely not fancy.
Yeah, he is. So this was the most frustrating part for me. It's unnecessarily frustrating. So GoPath is frustrating. It's just a tool set that uses an environment variable. You can set your GoPath to anything you want, but it's way easier if you set it in your home directory. Way easier. So open a terminal. And then these next few slides, we're just going to go through them, and you'll type whatever is on the screen.
So at this point, raise your hand if you type Go env and you do not see something that says GoPath that makes sense to you. We have never done this when half the room did not need help. We have done this a lot of times when half the room did not raise their hand. And then we discovered much later that they should have raised their hand. So at this point, we're going to pause until we're all here because we can't go forward until we get these things right. So raise your hand if you don't see the GoPath set to something you recognize. All right, I'm going to come around. We'll both come around and kind of look at your guys' things.
All right.
All right. Just raise your hand until we get to you.
Hard to get back there. How's everyone in the back? You guys good? It can be anywhere. It's just easier if it's at home.
All right, so the next thing is...
Your mic's not on. Oh, you are not. Okay, so the next thing, you want to check your go path. So check your go path.
Check your path.
Well, yeah, your path, sorry.
So we'll be installing Go binaries that you want to be able to run. So you need to make sure that your Go path bin is in your path. Okay, for those of you who did not have your Go path, the next slide will explain how to send both of them easily.
Turn your mic on.
It is on. It's off. It's having battery trouble? Hello? Yeah, it worked now. All right. Go to the next slide. Go to the next slide, too.
Yeah.
Okay. So run these two commands. Make sure you type them exactly like they are. If you miss one of the greater than symbols, it might mess up things. If you are not using bash, you should not type these commands like they're written. But if you're not using bash, you probably know how to change the commands to what you want them to be. Is anybody using Windows? Raise your hand if you're using Windows. Do not do this. Unless you're running bash on Windows. No.
No, nobody's doing that.
Yeah, I run bash on Windows. It works really well. All right, we're going to leave this up for a little bit for everybody to get through this. We recognize that some of you might be a little bored at this point. That's okay. It means that other people will not slow down the process later because we will all be starting at the same pace. While we're doing this, though, we could have some interaction with you. That would maybe break the silent tension that we have.
There's no tension.
So maybe we'll just ask for people, why did you come to this session? What were you hoping to learn?
Go.
You're in the right room. Anyone else?
How to set the go path correctly.
Yeah, that might have been a joke, but that was serious. That's
yeah,
serious
it's
business.
Too soon. It's too soon.
Anyone else? I saw a hand. Someone sneezed. Anyone else?
I'm trying to decide if Python for the Go is better for command types.
I think you'll have an answer by the end of this. Won't tell you which one, but you have to stay to the end. Anyone else? So for those of you who are looking at these slides and trying to type them feverishly, remember we gave you the URL earlier, and it's easier to copy and paste than it is to retype things sometimes.
How are you guys doing? Give it another minute.
Oh, there's one more thing that's important, which is do this. After you type those two things, type this thing, and that will make sure that it takes effect. All right. I think we're good.
We're good?
I think we're good.
All right.
If you're not good, raise your hand. I'll come help you, and Ashley will keep going. All right, I'm coming.
All right, so this is for you Windows users. Sorry, I can't help you with that. All right, so the first thing that you're going to do is get and install Cobra. So type this command, and you'll have it. Cobra is a CLI framework. It's going to help us. It's going to help us build it. You hate every single second of this, don't you? I can tell. So you'll just go get it, -V, in your terminal. Yeah. And we're not using Cobra at this moment, so we'll get into what that is more when we start creating our app.
Also, help your neighbors. We're all in this together. If you have questions, ask the person next to you. If you're a Windows user, find another Windows user and ask them for help. Other than the last like 3 slides, everything's the same. Windows, Mac, Linux, doesn't matter.
You guys have this? We're all good? Oh yeah, sorry, the network.
Luckily, we're only downloading like 2 things, so.
So this is Cobra, as I was saying, it's a CLI library. This is going to basically build your skeleton, and then we're going to customize it. This was built by Steve.
Important is to run Cobra and make sure you see something that looks like this.
Indeed.
If you do not see something that looks like this, if it says something like command not found, then we've got a problem. So raise your hand.
Still downloading?
It's finished downloading, but it doesn't do this.
Yeah. How many of you have Cobra downloaded? All right, cool. Wait 1 more minute. And those of you that have Cobra downloaded, is it working? Cool. Is this the output that you get when you type in Cobra? then it's working. Correct. Hold on a second.
Yeah, it's all of the packages will be installed in your home build per go per bin. Bin. And you can it's there and it is in the path attached also. It is perhaps not taken. Try to log out. Ah, okay, it is with Manchester.
Sorry.
Cobra, but I can't find it.
Okay. If it's not working for you, type echo space dollar go path in all caps and see if it's set. If it's not set, then we need to export it.
Where is everyone who has Cobra and who has it working? All right, that's going to be good enough. All right. So now we're going to talk about designing your app and like what features you want. So we are building a to-do application. So pick 3 things. I've highlighted what are the most common things, but what would you want your to-do app for? Suggestions. There you go. What would you want your to-do app for? Task management. So pick 3 things. You can add, you can list to-dos, you can mark done, search, priorities. I suggest these top 3. And then now we have an interface design. You're going to open a terminal at this point. You probably already have one open. Okay, so we already talked about this. Like, think of how you want to use your app. Pretend it was already built. What are you doing with it? And now we're going to sort of play with commands. You're going to get errors on all of these because we have not created the app yet, but that's okay. So, adding. We haven't got to the play part.
No, that was the play part. This is the design part. This is where we talk about what they played.
Okay. All right, let's go back to this. All right, type these commands in and just get a feel for it.
So what I like about CLI design is you literally don't need to know anything to write a prototype, because all you have to do is pretend it exists and start typing. And it's surprising like how unusable a lot of CLI apps are. And you would think if all they did was do this at the beginning, they'd realize, I don't want to type this horribly long, confusing Git command every time. If only I had prototyped it first by typing in an empty terminal, it would have saved everyone a lot of headache. So it might seem silly to do, but it's actually a really good exercise to do before you design something, is pretend it exists and play with it. It's almost like meditative. It's like,
Sure.
yeah, it could be. It's getting hot in here, huh?
Yeah.
I bet it's hotter down there. With the laptop on your lap? We're all in this together. Don't worry. We're going to sweat it out. This is the sweat tent. They're all the sweat tent, aren't they?
Yeah, they really are.
What happens if it complains about gold? What did you do?
How's everyone doing? Good? All right, we're going to move on. Everyone good? So now we're going to talk about adding. So we can type it, I mean, it's really up to you. We can do it in a number of ways. We can try add priorities and quotes.
Don't type this.
Don't type it, yeah.
Follow
We haven't
along.
gotten there. You can just follow along. You can do it like this. It's really up to you. Steve is way better at this part than I am.
So I think if we want usable apps, we need to be able, there's like a language that we need to be able to talk. And the language is, the applications are always nouns, the commands that we run are always verbs, and the things we pass them are always objects. You'd be surprised how many things that we use every day that don't follow this rule. But it's really important to design it in this way. So we've got this try is our noun, it's the name of our application. We want it to add, that's the verb, and then we give it the object. What are we adding? And we can read it like a sentence, right? And we can consider other things, like if we want to add multiple things, how we're going to handle that. But if you think about it, read it like a sentence. Try, add these two things, right? And we give it the names of these two things, or the descriptions of them.
Also, you can name your app anything you want, but for the sake of following along and not having any weird errors, I suggest you just call it try.
So if the Go Path experience bothered you, as someone on the Go team, we talk about this, and we are working to fix it. We will be fixing it this year. Things move slow sometimes when you have like a lot of users, but we'll fix it this year. If you're really upset about it, you can file a ticket on the Go project on GitHub, and that will definitely make sure that we have more resources, or at least when I do fix it, people will be a lot happier with me because they'll see all the frustration.
Or you can just mob Steve right after this.
Yeah, it's not going to get any faster. File the ticket. That would definitely be much better.
So we talked about adding. There are it's up to you, however you want to do that. And now we're going to talk about priority. So you need to prioritize your to-do list, like what is most important. You can do it this way, like a priority of 1. Same thing as what Steve was saying earlier.
There's a language to it, so these flags modify our actions, right? So how would we read this in a sentence?
Anyone?
That does not sound like a sentence. Like, how would we read it? Like we would say it to, like we would say it to like Siri or something. Like, how would we communicate with?
Yes.
There you go.
Can you put it at the end as well?
You could put it at the end.
You could. So we spell that out to you right here. Alternate syntax. Like I said, building this app is really up to you. As a new Go developer, I wasn't super stoked with giving you guys a ton of options, but Steve was.
Yeah, so I looked at a bunch of to-do apps, and there's like literally like thousands of them, because everyone wants to write their own to-do app. And a lot of them did this. Why would we want to do this approach, and why are we absolutely not going to do this approach? You can answer the first one first. Maybe.
You need to parse that. It's more complicated in an hour that we have.
Yeah.
Yep.
Or in general, right? Let's use the tools that are available to us.
And from a semantic point of view, you're mixing data with the way you're handling data.
Exactly. You would be shocked how many tools do this, but it breaks all of these rules. Yeah, you just get, so you know, right.
So things to consider, you can prioritize it numerically. You can do like this is high priority, this is low priority, or you can do it. Hi, Jason. Oh,
I did that.
you did do that.
Yeah.
Okay, so your to-do, earlier, prioritizing it, high, middle, low. Default to?
We're just going to use numbers
We're
because
just
they're
gonna use
easier.
numbers.
All right, so we got to think through our listing, right? If we have priorities, a real important thing is making sure we get the right lists. So like what's the command we're going to call it?
And there are multiple ways that you can do it.
Anyone?
List all items. Do you want to type that all the time? Sorry? Okay, okay. So there are a couple ways that you can do it. You can try ls. You can try list. This isn't right.
There's a Unicode.
Or you can just do try. If you are accessing this to-do list a lot, the less you type, the better, one would think. So when you type try list, what's the output?
Right, and how do we want to format the output? How do we want to order the output? Like these are all questions that we think about as we're designing the application. Right, do we want to set the priorities? Do we want to tab things in? You'd think these are things that you would just do, but it's important to consider them before we actually start creating the code. Right, and then you got to think about looking forward. Like when we do list things, how do we want to reference them if we want to edit them or do different things? So we have to consider all the different variables of how we're going to interact with our CLI application. All right, so maybe we add some labels to the side. And then the question is like how, we obviously don't want our entire to-do list every time. That can become quite overwhelming. So how are we going to filter it and find the exact parts that we need?
So we can use tokens like try list done or try list in progress. That's too many words, but you know, to do. That's weird. Try list to do. That's weird. Or we can use flags. So you can organize it by priority. Priority 1, 2, so on. You can also filter by priority.
Then we think, well, what if we want to like combine things, right? Does that do an and or an or operation? And we think flag is probably a good way to do this, right? Because it lets us have that kind of control and we can stack things together.
And we are going to be using flags.
And this is all what we'll be doing, yes.
So notice when you try list 2, it starts at 2.
Right, because it's filtering it out, but when we run there's no state between operations, so we need to make sure that we have a consistent state of the world before we do any editing. It'd be really weird if we renumbered the filters and then we tried to edit the first one, it was a different one than we expected.
Searching, so do you want to try list add?
That looks like a great way to do it. We're going to pass a token that you can search with, right? So that seems like the right time to pass an object in, right? We're not modifying it. We're actually passing in an object that the action uses here.
Or you can try list by and add by priority.
All right, and we have to make sure when we consider the app, are we handling many inputs and how are we handling those? All right.
And then update. And we're getting close to actually building stuff,
Yeah,
guys, I
I get a
promise.
sense that people are very excited to start typing.
I know.
Can I ask a question in the middle?
Yeah.
Yes.
With this listing stuff, you know, paradigm on Unix chat is often that you pipe it to grep and then you use that for filtering out this thing. You have a general paradigm here, how you balance that, building in functionality in your app, whereas being composable and playing well with the Unix paradigm?
Yeah, so I'll restate what you said. I think excellent question. He said, and it's a question we always have when we're designing things, right? Is do we want to bake the functionality in, or do we want to use the existing tools that are already there, like grep, right? Grep already does this filtering for us, Maybe we just want to use grep and pipe it out to grep. Maybe we want to build it in ourselves, right? And these are, good questions to consider when we're building our app. Of course, we're building it for ourselves, so if you like grep, you probably want to make that functionality work.
Try list is another way. So these are just ways that you can get the output that you want. There are lots of options.
All right.
And then completing, when you mark a task as done, are you doing it by number, like number 2 is done? And then editing number 1, improve listing. Or you can edit multiple things, which is probably preferable. If you have a to-do list, you probably have multiple things.
And it's important to keep the flags consistent. So we're using the same priority flags to change the priority as we are to search for the priority, right? And so the app has the same consistent feel.
And we get to consistency.
Yeah.
So be consistent while you're building it. It's just going to help you in life in general.
All right.
Batch edit. So do you want to edit more than one thing at a time? Do you want to edit one thing at a time? Think about that while you're building your app.
All right.
Creating your project. This is
All right. So now we're going to write code. From here on in, you're going to be typing a lot. You're going to be maybe confused. And we're going to ask lots of interactive questions as we're doing it. We will not be giving you the code that you're going to write, but we're going to collectively try and figure out what it should be.
So this is where we actually use Cobra. It's giving you the skeleton that you need. Like I said earlier, it's created by Steve, and it powers some pretty heavy hitters. Kubernetes, Docker, Dropbox, super useful. All right, so here's where we're gonna get to typing commands. So type it like you see it, and then make sure it's your handle and your name.
If you do not have a GitHub account, just make something up. We're actually not going to publish these unless you want to publish them, but it'll make it easier to keep consistent with the rest of us. And so what's happening here is Cobra is going to build you a skeleton application, really just give you the scaffolding to build your application. If this is not working for you, raise your hand. You do not need an internet connection. In
Because you
fact,
already have Cobra.
we're only going to get one more thing the rest of the time, so you won't really need internet much. Your name is your name. Like, if it was me, it would be Steve. Because it's going to add it to the copyright line. It does not work for you. It does. Raise your hand if it worked for you. Could one of you help this gentleman right here?
No.
I think we're...
Okay, we're going to move ahead
Move on.
now. Okay, so the path only really matters if you're publishing it, but it's safer to assume that it's always going to be published.
Yeah, it's a different change if you come from a different language. You can just kind of create a directory and use it. And Go, we kind of expect you to write things where they're going to live someday.
Go is frustratingly specific. It's only frustrating when you're learning. After you get used to it, it's awesome.
Yeah, there's really nice properties, but it's definitely an adjustment.
All right, so next you're going to initialize Cobra?
No, so it should have said this. Did your screen
No, yeah,
not
output.
say this? Raise your hand, but we already did that.
We already did it.
But I see. I'll encourage you to ask your neighbors for some guidance first, and then if your neighbor can't help you, then we will help both of you.
All right, now CD to your project.
Right, and so Cobra's created it for you inside your Go path. It's going to put it where you're going to expect to find all of your Go code.
I'm going to give you guys a minute.
Then when you're there, just look at your project, look around, see what it created for you. If you don't have the tree application, do not worry. You could also just use LS. If you're on a Windows machine, you could just use dir. All right, now once you're there, in the same folder as the main.go file,
Go build it.
do this. Woo!
Yes, sir.
Can somebody near him help him find his Go path and make sure the project's in it? I will help you then.
If you're way ahead, use that link from earlier and just keep working through it. You didn't get the link? Okay, cool. Oh, okay.
Okay, raise your hand if you've gotten this to work. All right, that's almost everybody. We are going to move along. Okay, so what just happened? Tell me what just happened on your machine. What? Say it louder. It compiled the code, and you ran it. That's pretty awesome. All right, congratulations. You just compiled and ran your first Go app. All right? That's pretty good, right? All right, now we'll actually type some Go code.
Steve.
See. Okay. All right, so the next slide, open the files in your editor. Which file? We said which file? Just open the file in an editor. Do you guys have editors installed? Do you have an editor you like? Use that one. If you don't have one you like, use one of these.
Pull the entire folder into your editor. You want to see this slide again? Is that what somebody said? So now we're going to edit our first command. So at the top here, you'll see the file that you need to have open. So next to the pink box. In that file, you should see this code already there for you. So packages, they're just a unit of organization in Go code. Go code is organized by folders. So notice that the package name matches the folder name. And these other packages are being imported. We are not adding anything here. This is just what you should see. You can change the short and long description to whatever you want.
Like that. And so, while we're here, we'll talk about what's happening here. Can anyone explain what's happening? Is everyone shy? Is this very confusing? What's going on? I can't hear you because... Anyone?
Anyone?
Yeah, that's what it will end up doing. But what's happening like on this slide, right? Okay, it creates a new Go structure and fills it with values. Okay, and what are we doing with their values? We're changing two of them. What are those ones that we're changing?
The printout we see when we type the command that's just the base command.
All right. Good. Oh, what that?
Is the ampersand what makes it a new thing?
No.
What's the ampersand?
Does anyone want, he asked a question. Let's go back to the slide so we
Yep.
see it. Okay, so he asked a question. What does that ampersand do? We will introduce that later, but since you asked it now, we will tell you now. Who, did you say it?
I said the difference is a pointer, but it has been defined since I do any C stuff.
Okay, and what did you say?
Memory index of the structure.
Okay, you're both right. All right. I will repeat it out loud for everyone to hear. So what's that doing is it is giving you a memory address or a pointer to the value. We could talk about why we did that here, but we will talk about that later.
All right, so once you've changed your short and long, go build it.
And then run it.
And then run it.
We're going to do lots of this, making a change, and then building it and running it, and hoping we didn't break it. Over and over again, in slow steps. So raise your hand when you've got the output you expect. So we got to wait a little while. While we're waiting for that, let's talk about the other side for some of the people. So, does anyone notice there are different quotes on this slide? You noticed. Why are there different quotes? Because of line breaks. That's right. All right, so there's a backtick. Backtick lets you have multiple lines. Does anyone have other things they'd like to talk about with the code on this? We're largely going to show you code and then talk about it, or not show you code and then talk about it, and then show you the code. I think they're still typing it.
They are. They are.
If a new version of Cobra comes along, how do I update my application?
So that's a good question. Currently, Go has absolutely no strategy for package management other than always pulling from master. Consequently, we will never issue a package breaking change of Cobra. So you can just go get -u, and it'll update Cobra to the latest version. We're hoping to fix that problem, and when we do, I would certainly love to release a new version of Cobra that fixes some of the things we learned. Anyone else? All right, raise your hands if you got to the output that you expected when you ran it. That's a solid 50.
All right, we already did this. So now we're going to create our add command. Add, that's not a typo.
Not a typo.
So Cobra add. So type in terminal, Cobra add.
What is happening here? Does anyone want to guess what's happening? We're adding a command called add. You don't need to read much. It's literally Cobra add.
Yeah.
The rest of it.
And
will
now you're
give
going
you.
to go build again.
But this time when we call it, we're going to call try add.
You guys there?
All right.
Sweet. All right, now we're going to make add. So go into add.go.
All right, this is a new file in the same folder as your other command. You'll notice the package is the same. And you notice it has a struct already there created for you.
So Steve already did all the hard work.
Well, Cobra did.
Yeah, well, same thing.
And just like before, we're going to change the strings so they match what we expect.
I'll leave this up for a minute.
Does anyone see anything interesting on this slide to talk about?
Ooh, Steve, why does printline have a capital P?
That's an excellent question, Ashley. Does anyone know why printline has a capital P? Because it's public. But in Go, we say exported. I don't know why, but we don't say public. We don't have private either.
What is the star in front of the
That's a good question. He says, what is this star? Does anyone want to guess what this star is? It's the value of the pointer. Close. All right.
All right, how you guys doing? You guys good?
What is the shortcut called? Like, so usually when you run it, it's at the long button parts. When is it short?
When you call help, it gives you that. Okay, let's go to the next one, which is
Yep, we're going to talk about
we're going to
functions.
talk about that. So did anyone see, I was hoping we'd get there, but no one asked, that there was a function. So before we talked about the slide had a struct, which had a bunch of values set to field names. Okay, the last value was a function. All right, and depending on what languages you may have already learned, that could be interesting or that could be something you expect. I think it's interesting that in Go, functions are first-class citizens. And it's its own type, and we treat them as values. And functions can have multiple input values, which if you've programmed before, matches every other language which has multiple input values. So now what we're going to do is we're going to take the function that was here as an anonymous function, right, because it didn't have a name, and we're going to move it down and give it a name. And then we're going to tell run what the name of the function is that we're going to call. Does anyone want to explain what we're doing or why we're doing it? There's no wrong guesses. There are definitely wrong answers, but there's no wrong guesses. I think they're busy typing.
Yeah, they're busy. You can't.
Some people are fast. If they're Vim users, they're probably done by now. That's all I'm saying. What? To be able to test. That is one reason we could do it. Because we like to name things. That's a good reason. It's a little cleaner sometimes than lots of embedded nested things. I think it's really interesting that all we have to do is give it a name and it knows to call that function.
Yeah, that was my question. How does it know how to pass the arguments? Because we are just passing a function reference, and then how does it return the arguments?
Because this is the value, and when the caller calls it, it's going to call it and pass in the arguments. Right? This is just a value. It's just a...
So that means that it expects to have this signature.
Yes.
And if you are wrong,
Then it will not compile.
Okay.
Right? So to speak what out loud, what he's this gentleman in the front who I can't see any of your names, so we're just going to say this good-looking gentleman in the front with glasses. He says, how does it know how to call it? Right? Go is a typed language. It's a statically typed language. This run can only be set to a function. You can't set it to a string or something else. And it can only be set to a function with this signature. Right? So it has to have a matching signature. It can have any name it wants, but it has to have that matching signature. And if it doesn't, the compiler will complain that you have mismatched types. It should. Yeah.
Where is the header defined for the signature? How do I know what signature I have to use?
In the definition of Cobra command. So if you open the Cobra package, you'll see that command is a type defined there, and it defines all of the field names, which there's many more than just we have here, and all of the types for those field names.
I would expect that command to have a return code.
Command to have what?
A return code.
A return code.
You would expect that. You would expect that. And it might, but this one doesn't. But some do. It depends how you're using Cobra, actually. There's another one called run E, which gives you a return code.
You guys all there?
All right, raise your hands if you've gotten to this point.
Awesome.
And So we're going to talk about one other part here. All right, in our add run function, what is that? Okay, we've heard array of strings. It's a slice of strings. Woo! That doesn't happen very often.
Never.
Okay, so what is an array of strings? What does that mean? Or a slice of strings, even better. And what is the difference between an array and a slice? Array has a fixed size. That's very good. Anyone else? A slice is a pointer to a segment of an array. That's pretty good. So in Go, we have these two things. One's called an array and one's called a slice. It's really confusing when you're starting to use Go, which one to use. Always use slices. Simple as that. Always use slices. If you're positive that you need an array, then use an array. But if you don't know which one you need, always use a slice. Slices are really cheap. There's really not a reason not to use a slice unless you know why you shouldn't use a slice.
And we just talked about that, so we can go past that. Same with a slice.
Right, so we didn't actually create an array. Even though there's an array underneath every slice, we don't usually work with the arrays. We just use slices. In other languages, they might be called a dynamic length array. Oh, that one's important. We got to talk through that one.
Yeah, talk through that.
All right, so we're going to introduce a new thing. We want to iterate over these, so what do we need? We need a for loop, right? Or a while, or a every, or each. But in Go, this is the format we use. So it's the very top of the slide. All right, what is going on there? Say it loud so I can hear. Okay, so we call for. The foo here represents a value that's got more than one thing in it, like an array, a slice, a string, a map, or a channel. And then it gives you the index and the value. Some of the things don't give you index and value. They give you slightly different things depending what they are. But for our purposes, this is the only one we're going to use, and it's pretty much the one you use. I think the slide explains quite a bit, and this is an important one. Sometimes you don't want things. This is an underscore. It's hard to tell on a slide. But underscore means don't name this variable, and I don't want it, right? So now we're going to try an exercise. This is really a test to see how many of you have been paying attention. Go to the next slide. So what do we put here? We could talk out loud as a group. It would be less nervous maybe if we combined the test together. Everyone does it. What? Yes, that is right. We're going to add the. Does anyone want to help us know what the code that adds an entry is? So I like to take things in small steps. So maybe we'll just spit out what the arguments that are passed in is, just so we know that we're receiving them right. All right, so how would we do that? What? We could do that. Okay, that would be the easiest way. What if we want to iterate through them? The for loop. Okay, so let's type. We're not going to go to the next slide. We're just going to let you try and type what you think it should be. And then we will show you what the answer is. But we're trying to teach you a new school. We're not trying to just have you like monkeys just type what's there. We want you to think and try and internalize and struggle and then succeed.
And frustrate you, yeah.
That's how you learn, is you struggle and then you succeed. If it's just given to you, you don't really learn anything. It's a really fair balance there, though, or else they'll have a mob out for us.
Yeah.
And when somebody gets something that they think is right, raise your hand and share it with the rest of us. There is more than one way to do this right. So what you have might not match the slide that we'll put up, and that's totally okay. You have a question or you have an answer?
Wow.
You have an answer. Okay. Can we use microphones for answers? That would be good. So just on a time check, we were planning on taking a break, but I think it'd be better just to push through.
Yes.
We have 40 minutes left. If you need to do something, go do something and come back. So we are not going to take a formal break. Just come back if you need to. Okay, can you share your answer with everybody?
Sure. I just wrote four underscore comma arc colon equals range arcs and then FMT print line arc on the next line.
Ta-da!
So how many people's looked exactly like this? Okay, whose looked differently? What did yours do different?
Because I printed the index, so I need to have the index.
Now, what if you, has anyone tried taking the index and then only printing the value?
Then it shifts.
Well, yeah, what does it do?
It doesn't compile.
It doesn't, did you hear that? It does not compile if you create a variable that you don't use.
Yeah, it goes really great. It's hard to make big mistakes. Or little mistakes. Or mistakes at all.
It's like,
Yeah.
it definitely does a lot of
It complains
things
a lot.
for you on compile time that kind of force you to not make silly mistakes. Like you don't create variables that you don't use, Go won't let you. You also can't import something you don't use, Go won't let you. All right, does anyone have any questions about what's going on here?
Is there a for without the index? I mean, if we're not using it anyways?
Yes. Yeah, so Go only has one iteration tool. It's called for. And for does all of the things that for and while and for each and whatever other iteration things do in other languages. So you can use for like a standard one with like an incrementer and then a check, a setup, a check, and an incrementer. Or you can use a for with nothing, kind of like C, which becomes a while.
Can I underscore the variable but give the name anyway? Just like prepend the underscore. Say I'm not using it, but just because I will forget what it is.
Can you name it anyway with the underscore?
Can I name it like if I prefix it with underscore, it's giving
No.
me an error?
Yeah, you can't.
So it's just like black hole. Like
Yeah, black hole. Yeah. Dev no, because we're geeks, right? All right. So let's go to the next slide. So we're going to create a new function. This is a special function in Go. It's called init. And init is called immediately after the package variable declaration. So when the program initializes is when it's called. Each package can have many inits in it, but there's no order
you
guarantee.
Shouldn't.
No, you
have.
can do. You shouldn't have more than one in a file, but a
Yes.
package can have more than one in it, and that's fine. So we're going to create an init so that we, in fact, so the init actually it's probably already there. You already have the init, right?
You do.
Okay, and an important convention is that the init, you can go anywhere in the file, but it's usually the first function that's called, right? That helps us keep track of this special function called init. There are only two special functions in Go. Init is one of them. We're about to talk about the next one. Main is the other, yeah. All right, so now let's try this and see what happens. All right, so if we did everything right, we should see an output similar to this. I see some people smiling, nodding their head like they've made a big accomplishment. They've succeeded for today. I see other people that are not as happy right now. All right, raise your hands if you did not get to this point. They're much shyer. Okay, raise your hands if you did get to this point and got this output. That was like almost everybody.
You guys are rad.
They're doing better than we are.
Yeah.
Definitely, but we've done this with Americans. Nowhere near as good.
Yeah.
Nowhere near as good.
So dumb. All right, so the other one is main. Special function.
Special function.
Super special.
Okay, so this one we want you to open, but we're not going to touch it. We just want you to see it, or you can just look at the slides. It's already here, Cobra created for you. It's you can see it. It's a function called main. It doesn't take any arguments. It doesn't return anything. And when the binary is called, when you run the binary, this is the function that gets executed. Okay, next.
So there can be only one, not like init.
There can be only
Yes.
one,
Like I wonder.
and there can only be one in one package, which is the main package. Right? So I think main, main, main. That's what you got to think. Main, main, main. It can technically be in any file name, but the convention is to call the file name main, which keeps it simple. And it needs to be the main package, and it needs to be the main function. And then the runtime will call main.main after all the inits are run. So it runs all the inits in all of the packages, and then it runs main.main. All right, and I want to point out here.
Wait. Previously you said that the name of the folder is the name of the package.
Yes, except for the top level. And the top level,
Okay.
you can call it whatever you want, but we call it package main. Like you could have other things in there. We want package main, and the only thing we want in there is package main. Right, so what I like to do with my Go code is I only have one package main, and it has one file in it, and that's it, and it only calls something else. Right, so my main usually has one line, and that, or sometimes 3 lines if I'm doing some error handling. So I want to point out one thing here, which is we've imported something, right? And you can see this in yours, right? And it's going to import it, and the tail of it is the name that it's going to import it as. All right, so what this is doing is we're calling the execute function on the command package, which Cobra created for you. Does this make sense to people? Does anyone have questions about this?
No, why are you prefixing it?
Ooh, why are we prefixing it?
With github.com/myhandle. Why is there the full namespace? Why doesn't Go understand that it's my module?
So this is a good question. So he's asking a really good question. Why is this so long? Why doesn't Go just know that it's here? In Go, for better or worse, and I actually think it was a great idea, although there's definitely some mistakes that we've learned from this, everything has an absolute path, right? It makes it really easy to find other things on the internet because there's no collisions. I can have multiple packages with the same name, and everything just works because they have this long namespace that's absolute.
Why not
Why what?
Why not
Why not .cmd? Because it doesn't work. And when I publish it and other people download it, .cmd, oh, it would work, but don't do that. Yeah, it does work. You can't reference the package directly if you do that. It's going to mess up tooling and other things.
Yeah, but that means that you hide your inner module from outside code in that case, which is might be what you want to do. Otherwise, that means you expose your shit to everyone.
No, you don't have to expose anything. You can keep it private. There's different ways to do it. But you should do, this is the right thing. You can fight against this, and I did for a long time, and it just causes headaches and problems. Like absolutely name things. It's the right way to do things in Go. It might be the right way to do things everywhere, but it is definitely the right way to do things in Go. All right, so we talked about that. That's a function name.
Yeah. We have a question? Sorry, I thought I heard
We have
something.
questions?
But you can import and then use only the shorts.
Yeah, you always just use the tail, the last element of it. That's the only thing you ever use. If you have a conflict, like you have 2 things with the same tail, you can alias one of them to something else by just putting the token in front of it.
All right.
Okay, so we're going to look at this. I think there's interesting things in this execute command. All right, so this is inside command root. This is what we just are calling in our root, in our main. Okay, does anyone see anything interesting on this slide? What? What is Well, you are definitely reading ahead. What is the error?
The error.
It is an error. Okay? It is a variable name for an error. So this function here, command root execute, returns one value, and that is an error value. Okay? And what else is interesting on this slide? What? Nil. Okay, why is nil interesting? We haven't seen it. We haven't talked about it yet. Maybe there's a couple other things we haven't talked about yet.
What about colon equals?
So she just said it.
Oh, good for you.
What is semicolon equals? Has anyone programmed a language that uses that before? Yeah. See, in Europe, people raise their hands. In the United States, they have to be old like me to know what Pascal looked like.
It infers the type from the root command.execute.
All right, so
Instead of adding a type and then the value, it just takes the value and infers the type.
that's right. I'll repeat what you said, which was perfectly accurate. All right, so this is called the assignment operator. And what it does is we have not previously said we have a variable called error that's of type error, right? Which static languages, a lot of them you'd have to do that. In this one, we just use error colon equals, and it infers the value, the type from the value that's passed in, right? And it does it all in one step. And it's just syntactic sugar. We could do it the other way, but this is a lot shorter, and it makes code a lot nicer to type. And, so there's a question sometimes people have, well, should I declare all my variables ahead and then just set them with the equal? And the answer is no. Most of the time, this is totally the right way to do it, and it keeps things very clean. All right? Do we need to import? We do. This package already does, but yes, it would need to if it's going to use it. So if you look at the top of the file, there's an import, and it does import package OS. I think we've got most of the things. All right, we talked about this.
We talked about that.
We talked
Also
about all these
talked
things.
about it.
I got it right, too. That's good to know. All right, we talked about
We
this.
talked about this.
This is how we like to do it. We like to have the conversation and then see what we recap as we go.
You guys are too smart is the problem.
All right, so we'll just come right out and say it. There are no exceptions in Go. All right, what does that mean? People say, how can you write a language without exceptions? This cannot work. Well, guess what? It works. It does, and you can say that. And it is uncomfortable if you're used to exceptions because it's a new way of doing things. But as someone, I've been writing Go for 4+ years now, I don't miss exceptions. I'll be honest, I don't miss them.
You always have to check the return codes.
No, you could write bad code. But it says at the bottom, errors should be handled when they occur. We're not waiting for something upstream or down the stream somewhere to catch it. They should handle them when they occur.
Not really.
Well, this is the Go philosophy. You can have your own philosophy, and that's fine. But in Go, this is proper Go, is handle them here. Sometimes you handle them, and you say, I actually don't want to handle this. I am going to pass it to my caller. Right? And that's fine, too. Or sometimes you do handle it right there.
It's like checked exceptions, but they are not called exceptions.
Right? It's like there's no you have to handle them.
Yes.
Right? You can't ignore them. All right? And the philosophy here is that errors are not exceptional. Right? Errors are normal. We have errors all the time. We're always passing errors. So why do we treat them with this weird exception? They should just be handled like all the other values. And Go does that. That's the theory, and in practice it works. It works really well.
The original concept behind exception is that you could separate the normal flow from the exceptional and ending flow, which is a good thing.
Yeah.
Now, whether they were mishandled, that's another question.
Right. And the Go designer said, that is a good thing. But it causes lots of problems because a lot of people don't do it. It's much better if we just have it here. Plus, it's built into the language. It just uses regular language concepts. There's not a new feature to be able to handle it. So a lot of the Go designs are people that, there are good ideas that we did not include in Go. There's reasons behind every one of those. I know some of those reasons. I wish I knew all of those reasons. We are working on sharing more of those reasons. We have to soon because the creators are all getting old. So we better start documenting things. Okay. Does anyone have questions about errors? Yeah, we didn't touch on panic, okay? Don't panic. There is something in Go called panic. You should not ever use it. Really, that's it. You should not use panic. Panic is if you're writing like very low level, like networking applications, and something really gets in a state where you can't handle it anymore. There are very few panic calls in the standard library, and that's probably the right place for all of them.
It just crashes, or?
Yeah, it does a full page dump. It's not good. You can recover panics too, but a lot of people are like, hey, panic, that kind of looks like exception. I'll use it like an exception. Don't use it like an exception. It's not an exception. Really, don't use panics. If you get to a point where you do things and you know, this isn't working, I can't just use regular errors, then you know, okay, I should probably use a panic. But chances are you will not be writing that code anytime soon if you're in this room. All right. Any other questions? All right. So just on a time check, we're about 25 minutes left. We have designed at least 5 hours of material because we have no idea how fast each of you are going to be. And we figure people might want to work ahead or people might want to work later on it. And so the code is yours, the code's there, the slides are yours. You can keep going. We're not going to get to the end. We're not intending on getting to the end. We've never even gotten halfway through it. And that's by design, right? Because every room that we're in is a different pace.
We cut about 100 slides for this.
We still have 300 though.
Yeah.
So, all right. So now we're going to create our data model. All right. So we're going to create a new package. We haven't created a new package yet. This is our own package we're creating. Okay. So before we do that, where do we create a new package? What's the first thing we should do? Create the folder. So we should tell them what the name of it is.
Yeah, we should.
All right. So we're going to create a new package called to do. You could name it anything you want, but it'll be a lot easier if you just call it to do. And then inside of that, we're going to create a file, and that file is going to be called to do. And important, we're going to put one thing in that file, which is the line package to do.
Excuse me, guys. We have 15 more minutes instead of 25. The timer, okay?
The timer was not accurate.
Okay. So we have 15 minutes,
We
okay?
have 15 more minutes.
All right. Thanks.
Also, if you have questions after, we are on Twitter or email. That's in the slides.
And,
We're willing to help
we'll be
after.
hanging around.
Yeah.
All right, so
Yeah, we're going to go.
all right, so now what we're going to do is we're going to do this. So I want you to type this, and while you're typing this, let's talk about what's happening here. Does anyone want to suggest what's happening on this slide?
Creating a sort of structure for data. So we say we want something that has a string in there. So
Okay.
kind of like an object, but more low level probably.
Okay, so what you're saying is not wrong, but it's not precise, which is we're creating this, he says we're creating something that kind of looks like an object that has a string in it. That's accurate. Can anyone help him be more precise?
Signature for a struct.
Okay. It is a signature for a struct. Anyone else?
Data structure that means there's no behavior, it's just dumb, stupid data structure.
I would not offend it like that.
Yeah, but I come from OPs.
Okay. It is only data. We'll say that. It's only data right now. All right. What else are we doing?
The text is topic.
We how do we know that? What?
Because of the capital N.
Because it's got a big T. All right. The big T tells us this is public or exported. All right. What else is happening here?
So you have a struct called item with a string called text.
All right. So we're defining a new type, right? Just like string is a type, right? We're defining our own type. Okay, and this new type has a name. It's called item, right? And it's a type of type struct, right? So it's a new type of struct, and it has one field in it called text, and that is a field only can have a string in it. Does that make sense to people? It is kind of like an object, but it's not an object. It's a struct. Has slightly different properties from objects. Go does not have objects. This is as close as you get to what you traditionally would think of as objects.
You guys there?
All right, next. We talked
Yeah,
about
we
that.
talked about it.
Well, you didn't talk about that, but it's true. Item was also uppercase, so we are also exporting this type. So other packages can use this type. Okay? As soon as it's uppercase, it's exported. There's no public, private. There's no other things. One really actually, there's two really important things to know about this. Well, all three of these are important. We've got three important things, all of which are on this slide. The first one is you can create a new type that is not just a struct. You can create a new type that's a string or an array or a slice or a channel. You can, just like object-oriented program, you can define methods on your types. On any type that you create, you can define methods on it. And this is important, is it's not an alias, it's an explicit type. So even if I have something that looks the same, has the same structure to it, it's a different type. They're not compatible. All right, so now we're going to use our type, we're going to add it. All right, so first thing is we want to import this new package that we just created in our add command. So go to our add command and type this in, and don't hit save yet. And why did I say don't hit save yet? What? Because we haven't used this import yet, and some Go tooling is really smart and says, I'm going to delete all the imports you're not using yet. And some of the Go tooling is really smart and says, I'm going to add imports that you haven't defined yet because you're using them. And maybe you've installed some of those things, and then you're going to be really frustrated why it keeps being deleted. All right. All right, so now we have an add run. Do we have an add run? We have add run. We have add run.
Yeah.
All right, but we need to populate it. So we had some structure there before, but we're going to change it a little bit and try and use this new type that we created. So what should we do? And we'll take, there's three questions here. Why don't we take it from the top down? What is the first thing that we would want to do? This is not an easy question. You're going to have to like put together a lot of different concepts we talked about. Hold on, I'm going to try some new people because we've got some brave people and then we've got the rest of you. So let's try some of the rest of you. All right, does anyone feel confident that hasn't spoken up yet, that they know what this is? All right. You should have spoken up earlier. That's the perfect right answer. We should create a slice of items that we want to store it in. So let's do that. Now we've created a slice of items. Now the syntax here is a little interesting. We've seen that syntax before in some of the earlier slides, but what is actually happening here? If anyone's familiar with like static programming, like compiled programming, this might look interesting to you. If you're familiar with dynamic programming, this actually kind of feels normal. What's happening on this line? We are not creating a slice from an array, but that's a good guess. We are not creating a slice of a string. We are creating a slice of items. We are creating a slice of items. Right? This part of this is actually creating an empty slice of items. It has no values in it. Right? We didn't have to like define it ahead of time. We're just creating it there. And then we're assigning it to the variable name items.
Do you really need the two brackets at the end?
Yes. Yeah, that's the creation. Other than that, it's just a type. Right? So by putting those curly brackets on the end, and we could put values in there, but we're not going to because we want the empty one right here. This is a very efficient way to create new things in Go. What? Yes. Okay, and we'll talk a little bit about this. Go doesn't have constructors, right? If you want to use a constructor, like you have something that needs to be set up before you use it, then there's a convention of using new and then the name of the type. Or if it's the only type in the package, just new. All right, and what we just talked about is composite literals. That's the term for this expression that always gives you back a new value. Right, composite literals are, there's like multiple ways to initialize things in Go. That is the best one. Use that one. Like, they're all about the same performance. There's not really a difference, but that one's consistent and easy. And it's very clear. All right, so I also added this to the bottom here. We're just going to print it at the end. But the middle part, what should we do? What? Create an item. How do we do that? No, we do not use new. That is the wrong answer. We just talked about why we don't do that.
Using curly bracket.
Use what?
Curly bracket.
Which is called what? We just said the name. Like composite literal. Thank you. All right, so let's do that. So we're going to kind of do that, but we need to add things to this slice. Okay, so in Go, there's one way to add new things to a slice, right? And that's called append. All right, so this syntax, append is a keyword that it's like a base function that always does this, right? And pretty much the syntax is always the same. Although you can append to different things, pretty much you're using it to add on or grow something. So this is pretty much a push operation. Okay. And we already talked about what to put in the open thing there, so tab to the next slide.
We already talked about append.
Oh, so append is what makes slices awesome. All right, so append is really what makes slices dynamic, is when you call append, it does all the adjusting of sizes and makes sure that it balances it properly. So it's a really, really brilliant tool.
Does that mean that you are creating a new object with this syntax?
This is not creating, I'm trying to think, this does return, it is creating a new, it returns a copy of it, but remember it's a pointer, right? Because slice, so it's not like copying the entire underlying array, it's just making a copy of the slice, which is just a pointer. So it's very cheap. The underlying thing, it might copy if it needs to, or it'll just insert into the array. So if there's enough room in it, it'll just add it. If there's not, it'll allocate a new place and move it.
I can just use add-on and so on without items control.
It will not return it to it. Because it is not, you have a great question. We do not have time to address your question entirely right now. There is a blog post that was on Hacker News yesterday called Pointers in Go, or References in Go. And you can search, it's on Dave Cheney's blog. It explains it. But it's not going to manipulate that. We need to return something. It's a longer explanation than, we have 3 minutes, so.
Yeah.
Okay, so does this look like what you were thinking it looked like? We haven't done this before. We're actually providing a value to it, right? So we still have the same curly braces before, but inside of them we're actually giving it a value, or we're using a field name, and we're giving that field name a value. And this syntax uses a colon, which is important because it's different than the other things. All right, and let's, yep. Can you go back?
So at the beginning, you initialize empty slice. But
Empty
The
slice.
slice is not new. But normally what we do, what I do is I declare slice, which is new, and append it.
You could also do that.
Yeah, I guess that saves a little bit, tiny bit, right?
No. No, unless you never, no, it doesn't save anything. It's trying to think, if you don't use it at all, it might save something, but not much. All right, so once you're done with that, we're going to do what is going to be our final build for today. And then we're going to do, okay, so this is the last thing I want to show you. We've done a lot of go builds, and then we call it. And there's a shortcut called go run that does the exact same thing as go build and then running it, except for it doesn't actually create a binary sitting there, and you don't have to run it. So it does it in one step, but it's also kind of weird because we're actually calling things after like the name of the source that we're doing it, which is just kind of a weird syntax. You get used to it, but this is really, you do this all the time. One of the interesting things, so how many people here generally program in dynamic languages? The rest of you program in, what do the rest of you program in? Are you all C programmers, C++? All right, all right. So Ruby, okay. Really? Look at you. All right. So one of the nice things about Go is you'll do this, you'll realize it's really fast, right? Like a lot of other languages, C++, C, even Java, take a long time to load up things and compile them or load them into the VM. Go is really fast. In fact, doing this is generally faster than it takes to just load it in Ruby, even though it's doing the full compile and the run, or Python, or PHP, right? And in fact, it feels, because it's so fast at compilation, it almost feels like a dynamic language, right? Which is one of the nicest properties of Go is you get really fast iteration and feedback loop. All right, so we're wrapping up on time, and we're at a pretty good breaking point.
Yeah.
We've gotten like maybe a quarter of the way through all the slides that are there. But we encourage you to take them and build your own app and play with it and look through the slides and ask us questions on Twitter. But with that, I think we're gonna.
Let's go.
What are we gonna?
back
We're gonna
to
go all the way to the beginning.
To the link.
Yeah, there we go. So if you missed it, we'll leave this up here. This is the. Was that someone's private chat?
Yeah, I don't know.
All right.
Probably.
Someone saw it. They're laughing, so something happened. All right. So this is the URL. I'm Steve. Yo,
Ashley, I'm sorry.
Oh,
It's time
good
to shoot.
grief.
Thank you guys for the
Ashley.
excellent